Welcome to this edition of Pipeline Things. Thank you for joining us. In this episode, we get real on the subject of MFLA, and my boy Christopher De Leon talks a little bit about limitations, some of which even you may not be aware of. Thanks again for joining us, and we appreciate you. Remember, like and subscribe. They made this look a lot easier on the Super Bowl.
This week's edition of Pipeline Things. I'm your host, Thing 20, known as Rhett Dotson, and my co-host, again, not lesser in prominence and stature, but definitely less funny, Thing 21, Mr. Christopher De Leon, and welcome to the show about all things pipeline related, where we hope to do a little bit of education, a little bit of humor, even someone like maybe your mom, if she's not in the pipeline industry, can get something from today's episode.
My mom has still not listened to it.
That is disappointing. You've had 3 episodes now.
But I've had multiple cousins listen to it.
Hey, that's pretty good. My mom has listened to it, and I don't think I've had any of my cousins listen to it.
They've also now applied for jobs in pipeline. They were like, if you guys are in pipelines,
if you guys can have this much fun, so you too can aspire to be a part of the pipeline industry, and maybe one day work your way onto the Pipeline Things podcast.
As Chad Zamrin would say, we need to attract talent in the pipeline industry.
We had follow up. Yeah. We had some homework from last week's episode. Did you contact Morgan Freeman, Miss Producer? Has he? Better yet, has he responded? I saw he was on a commercial in the Super Bowl, which I
honestly didn't even see the hashtag Morgan Freeman, so he could while he's on his downtime looking to see who hashtags him. We could have done that.
Yeah, okay, so Morgan Freeman's not only this producer's giving us I think this, when they do this symbol, I don't think Nisha wants to kill us. I think she means we're supposed to stop.
Yeah, so last time we were talking about our favorite parts of the year, right?
Oh.
And I said we had at least 2 favorite. The
Yours
first one
was
Christmas.
Rodeo.
And now the next best.
You have can we take guess? Do you want to guess? What do you think is third best would be?
There's a third favorite
Miss
season.
Producer? Come on, what do you think it is? God, got an idea? Birthday?
About the Super Bowl?
No,
is this for
God,
no.
Crawfish season. Come on, guys. Crawfish season.
Okay.
This is when you get to pay $10 a pound for mud bugs and
$10 a pound, but it's probably even more expensive by the time you only get half of the thing out, and you spend 20 minutes getting that half of the thing out, right?
Yeah. So Super Bowl, did you watch the halftime show?
Dude, I did watch the halftime show, and apparently I'm in the minority. I loved it.
It was good.
It was nostalgic for me, right? So,
can you name all of the rappers or artists that were in the halftime show?
See, why are you gonna put me on the spot like that, right? Okay, so there was. All right, let's do it. There was Dr. Dre. There was Snoop Dogg, Eminem, Mary J. Blige, Kendrick Lamar, and 50 Cent. That's 6.
Good job. Good job. I'm glad you caught Kendrick Lamar. I thought they were going to have to put a little one of those pop-ups that says who each rapper was.
People told me about him, to be honest. I didn't know who he was on the show. I'm like, who is this guy? And so, fortunately, I have people who listen to Kendrick Lamar, and they were like, it's Kendrick Lamar.
Yeah, stay humble.
Yeah, so that's one of his songs. I know you're getting
Sit down.
I get it. Now that we've effectively lost
half of our listeners,
the people that were upset at the Super Bowl halftime show have now tuned out. But before the Super Bowl halftime show, there was also PPIM, and we have not had a chance to recap PPIM.
Yeah.
So impressions from this year's PPIM show? What'd you think?
Great to see everybody again. I think that we did a pretty good job of being present, and it was nice. It was really awesome. So cheers to all the exhibitors who made an effort to go out, and all the operators and interested parties to participate, come by the booths and say hi and have a good time.
So one of the things we probably need to do is explain to everyone out there. So when we say PPIM, that's 4 letters in quick succession. Again, that's the Pipeline Pigging and Integrity Management Conference. Happens every year in Houston, and it's a 34th year, actually. And like most conferences, it's been a real challenge. But I think the folks at Clarion and BJ Lowe, really shout out, kudos to you guys. Y'all did a great job. Yeah. I think it's so important for us as vendors on our side, really to be back supporting that. I mean, it really felt good to see people back together, interacting again. It feels like, we had a lost year or two in the pipeline industry where we didn't really see people.
Why do you think it's so important? What's one of the aspects of it that you think is so important about PPIM and other type conferences?
Honestly, straight up, relationships. Bar none, right? I don't think it matters what industry you're in, but I don't think it's unique to the pipeline industry. Relationships matter, right? And in order to preserve relationships, to preserve relationships with people, you have to interact with them, Chris. You got to have a conversation with them, and you get the chance to go there and talk. You find out what's going on in their lives a lot of times, and then you also find out what's going on professionally, right? So one of the things I like is also the papers are very down to earth, boots on the ground type papers a lot of times that you find, and I find it personally educational. So, what about you? Why did you want to be there?
I think relationships are important, but it's also when you get to reestablish that level of trust with your network, right? So it's kind of the things we always advocate is ask for help, and normally you call the people that you trust. So I think it creates an environment for you to reconnect with your network and reinstill that level of trust in the people you work with. And then the second one, which is a very near and dear topic to my heart, is it's lessons learned, industry lessons learned, right? So a lot of these papers or presentations are based on something that has happened, and they want to communicate for the greater good. Hey guys, this is what we're doing. This is what we learned. How can you take advantage or learn from this, right? Because it's one pipeline industry.
And that's something I think that's a challenge sometimes, is if you miss a conference, and most of us don't have enough time to just sit down and read all of the conference proceedings. We're probably lucky if we can scrab through the abstracts, right, and just get through that. You can really miss sometimes what are really great lessons learned. So I don't know which paper stuck out to you, but I had one that stuck out to me. And that was the Exceeding Performance Standards of Pipeline Integrity. It was actually a inspection. That title is long, so I'm going to boil it down. It was TC Energy and Baker Hughes, and they were talking about how they use data analytics and the result from a whole bunch of excavations to improve the performance of ILI technology, specifically MFL-based ILI technology. And the reason I like that paper, Chris, for me, is MFL and the use of MFL precedes you and I both being born, right? I mean, we have been using MFL.
Are you sure? You've got a lot of grays now, but
I do have a lot of gray,
but it's your eyebrows.
It's misleading. Is it really?
Yeah.
I'm gonna be self-conscious about that now. I'm gonna go back. I'm gonna have to get like one of the eyebrow pens and start drawing it. I can't believe you said that. My gosh, receding hairline, isn't it? Now
I didn't say receding hairline. That's on you.
Before you know long, I'll be with a mortician. And
so MFL's been around since the 70s or 80s, right?
Yes,
I think
it's been around.
70s.
It is. So it's been almost like 50 years, right? And we are still learning about MFL technology, right? And actually, what I thought was kind of unique about this is when you think about the MFL technology, lessons learned. And this paper actually wasn't on the basis of a failure, which is nice. It was just purely around using data analytics. But this isn't the first time that TC Energy and Baker Hughes have partnered to write a paper that I thought was pretty good. One that you and I have often talked about with operators, and I feel like flew under the radar. Was actually an IPC paper from 2012. Do you happen to know the name of that paper? Or do you need me to give it to you?
I don't. I just remember the subject. The subject was dealing with complex corrosion as a result. I think it was a 2009 failure that TC Energy had, where they were surprised that they had inspected the line a couple of times with MFL technology.
How many? Do you remember how many times?
9?
Yes. Oh. It had a lot of it. It was shocking. It was a shocking number of inspections that for a line in 2009 they had. The paper that we're actually talking about here for the audience, if you want to look it up, is IPC 2012 90529, and that the paper title is Overcoming Technical Limitations in Identifying and Characterizing Critical Complex Corrosion. Really long title, so we're not going to go through this.
That was
paper.
a decade ago.
It was a decade ago in 2012, but look, we've had multiple conversations with operators, Chris, and very few people are aware of what this paper talks about or what lessons I would say both TC Energy and Baker Hughes learned. And given the importance of MFL technology to our industry, I mean, corrosion is the oldest known threat acting on pipelines. It's the one we have the most experience in. And so given MFL is critical to our industry. So I think this is a good topic for this show.
All right.
So that's where I want to jump in, right? And I want to boil it down for the operators. I want to give them for the people that are out there, give you a little bit of background of this paper. Chris has already alluded to it. TC Energy has a failure around 2009 due to what they labeled as complex corrosion.
Yeah.
The real concern was, how on earth? We've inspected this pipeline. We're going 9 times.
Yeah.
How did we miss this feature in our corrosion growth assessments with the repeat inspections? If we're going to know a line, we should have known this line, and we missed the feature.
Yeah.
So let's start there. But before we do, because I think we're going to get around to the points of this paper, I want to use this as a chance to talk about MFLA,
Yep.
ILI. Those are 2 terms. I want you to please define them for the audience.
Sure.
And then let's go through it. So let's start with ILI.
You got it. ILI stands for inline inspection.
Right. And we inspect pigs. Again, now I'm going to take some of those that are maybe more advanced. Y'all might find this fairly rudimentary. My mom is going to learn a lot right here. Okay. So, ILI.
Yes.
All pigs are the same?
No. Typically, it's really important to think of an ILI as an activity. You're inspecting the pipeline inline, but what we use is actually an ILI system.
Okay.
Right? And an ILI system is normally a non-destructive testing technique. So it's actually NDT. It's a form of NDT, inline. And inline meaning you've introduced it into your pipeline and it's navigating some length of it and it's performing an inspection. And we call it an ILI system because it comprises of a tool, which you could think of like a mandrel or the physical part that's moving through the line. Normally you'll have some kind of propulsion mechanism, right? So it's either being pulled through some kind of tether, cups to seal for it to move, and the body that you mount all of your sensoric technology. The other part of it is it's what type non-destructive technology are you using, right? I usually like to use the term measurement principle, right? So what is the measurement principle you're using that you've turned into some kind of sensoric technology or sensor that is performing the inspection? Then you have downstream of that some kind of evaluation protocols on how you're evaluating the data this inline inspection tool has collected. And then you have all the processes and procedures that go along with how you prepared the tool to how you inspect it properly to how you evaluate it and how you report it. So all that makes up an ILI system.
So layman's terms, we take a highly complex piece of equipment.
Yep.
We stick it in the pipeline.
Yep.
We shoot it down the pipeline.
Yep.
Propelled by whatever is in that pipeline in most cases. That has sensors on it that record all sorts of information about the pipeline.
Yep.
That's the NDE part. Somebody takes a look at that data and determines what is physically going on in your pipeline.
Yeah, so that was the NDT part, and then when someone looks at
Absolutely.
it, that's the NDE part, the non-destructive
So that's
evaluation.
ILI.
Yep.
Important thing to note there is that not all, and we're talking about smart pig technology here, right?
Yep.
We're not talking about cleaning pigs, we're talking about smart technology. All right, so now that we've introduced ILI, let's introduce MFL, because that's the technology under concern here. MFL, go.
Yep. So MFL stands for magnetic flux leakage. Basically what you do is you have a steel pipeline, and because it's carbon steel, if you think about it, you can put a magnet on it, it'll stick to it. And so if you remember the horseshoe, basically you have flux lines
Nobody knows the
that are
horseshoe
going through the
leak.
line. So a horseshoe magnet, right? Imagine you have a magnet
Okay.
like in your Looney Tunes cartoons.
Remember, my mom's
right?
listening. So
Looney
a
Tunes
horseshoe
cartoons,
magnet.
horseshoe magnet. You put it on the metal. Basically, it's the magnetic flux that draws all of the attraction, right? So the idea there is if you put a sensor in between the North Pole and the South Pole, then as you are traversing through the pipeline, if there's not enough material to house or to hold all of that magnetic flux will have to go somewhere. It'll leak. And so these sensors will detect how much magnetic flux has leaked from the pipe wall. So the basic principle of it is if you have all of your material, you won't have a lot of magnetic flux leakage indications, right? The sensor won't pick up a lot. But as you have reduced metal or i.e. corrosion, or you have a change in your wall thickness, that flux has to go somewhere.
So it leaks
and so
out.
when it leaks, then the sensor picks it up, you get a signal, and then it can be interpreted.
Okay, so I'm sensing a theme in this episode.
Yeah.
Technical explanation, layman's terms, right? So think about it another way. If horseshoe magnets didn't do, because I was thinking like horseshoes, close only works in horseshoes and hand grenades. That could be the thing where close only works in horseshoes and hand grenades. We could talk about hand grenades today. All right. Think about it a different way. I like to think about water flowing through a stream, right?
Okay.
I was a civil engineer. I wasn't electrical, and I wasn't mechanical, right?
Okay.
So I didn't like flux. I actually hated that whole course in college. So I like to think about water flowing through a stream,
Yep.
right? And then I look for things to disrupt that water flow. And in
Okay.
this case, like in a stream, it would be like rocks and boulders, like when we go to Colorado and whitewater rafting. Think about magnetic flux in a pipeline, like the magnetic flux is the water flowing through the wall or the steel of the pipeline, and every time it hits a corrosion pit or missing metal, it gets disrupted and flows out around it. And we're looking for those disruptions in the water flow.
Yeah.
So whichever option works for you, we should have asked.
So it's a good
our
point.
producers
No.
which one they would
So
like better.
that's a good point. So if you think about it, so MFL actually comes in at least 3 classes right now.
3 classes?
Yeah. So it's MFL-A, MFL-C, or there's another tool out there which is S. Right. So A stands for axially oriented magnetic flux, which goes along the pipeline, the direction of the flow of your product in your pipeline. C is circumferential. So the magnetic flux is traveling, think of like clock position, right? So from top of pipe to bottom of pipe back around. And then you have S, which stands for spiral, where it's going at an oblique angle.
Right.
And the reason why that matters is because the orientation of the flux, the magnetic flux, will be a big part of what type of metal loss features you'll be able to find.
Right, so you're jumping into, I think, the next critical part of this paper, right? So now we hopefully, if you're in there in the audience, you kind of understand the basic premise behind magnetic flux leakage as a means to identify, let's say, metal loss characteristics in the pipe, right? That's an important jumping point because every technology has limitations, and MFL has limitations, right? So let's talk about, and they really hit on them pretty well in this paper. I'm going to give them to you.
Okay, go ahead.
And let's talk. So first limitation was local pits within larger pits.
Sure.
So I want to describe what that is, right? So in this particular paper, it was assigned due to MIC, which is microbial-induced corrosion.
Yep.
But think about, we have a large area of metal loss. And then within that area, we've got a very local, smaller area of metal loss.
That goes deeper.
That goes deeper, yep. So let's say it's maybe 30% of the wall nominal over a really large patch, and then bloop, we got a little 60% in there in the middle.
Yep.
Why is that a problem for MFL, Christopher?
Sure. Because magnetic flux leakage is a relative measurement. And so the flux lines that leak from the pipe wall are going to be detected on a relative scale. So what that means is if you have full wall thickness, that means you'll have a certain reference of how much flux leakage there is. And so when you get some metal loss or some corrosion, your sensor will pick up that flux leakage. But if there's enough area corroded, that change, right? Because MFL is really good at detecting change. It's kind of like normalization of deviance, right? Your baseline normalizes to the new normal. And so if you have this huge pool of corrosion, you saw the initial change, but then that kind of becomes the new normal. And so if you then have a pit within that larger pool of corrosion, you may get some flux leakage there, but it's really difficult to say, is that 50% deep or 80% deep? Because it's really good at finding change, but because it's relative, it can be difficult to quantify exactly how deep that pit within a larger pool of corrosion is.
And again, you're saying something here that I think is really important for the audience to understand, because I think the majority of our clients, the majority of people in the pipeline industry, unless you're an MFL specialist, so to speak, believe or interpret that MFL actually takes discrete measurements of the pipe wall.
Absolutely
right?
not.
Absolutely
not. So it's the opposite almost of like a UT measurement,
yes.
right? So if you think of this UT probe, you're standing on the outside of the pipe and you have one shot for a very discrete point that you're shooting through the wall thickness, getting a reflection and saying, this is how deep this point is. Very much like how we use our string, right? Or when you're trying to do a defect assessment of corrosion, right? You do 1 inch by 1 inch grids over the area of interest. You go into each 1 inch grid, you use your UT, and you take a discrete measurement. MFL absolutely does not do that.
Right.
Whether it's standard resolution, high resolution, or ultra resolution.
It's a relative off of a baseline.
Absolutely.
And that baseline becomes very important. And if that baseline is impacted, for instance, it can affect something relative.
Yeah.
This is a good point for us to take a break because we're only in one of the first 3 limitations of MFL, so we're going to be right back and talk about the next 2.
Hi, my name is Chris Alexander, and I'm president and founder of ADV Integrity, and we are the proud sponsors of the Pipeline Things podcast led by Rhett Dotson and Christopher DeLeon. In that podcast, they're going to be talking about things like integrity management, pretty much anything related to pipelines, including regulations, technology, and anything that you would need to know. They're also going to be talking about current events. For those of you that don't know anything about ADV Integrity, we're a consulting company. We do full-scale testing. I'm actually here in the lab, and really high-end engineering to serve the pipeline industry. And we would love to hear from you, and really excited about being sponsors of the Pipeline Things podcast.
All right, welcome back to Pipeline Things. Thank you for the break. And we are picking up in the middle of our discussion on actually the limitations on MFL technology, right? So the first one we covered was local pits within larger pits. The second one that was in an IPC paper was gradual wall thinning.
Yeah, so that alludes to that same challenge, right? And what you're hitting on there is it's because MFL is a relative measurement. If you have this gradual change, then the MFL tool, which is good at detecting change, will struggle to identify how much change has actually occurred over that distance or that time.
Right.
So that's what they're highlighting.
So I want to say it's another way. Is it true? Like, let's say you had a piece of pipe and the nominal wall thickness of that pipe was actually thinner out of the mill. So let's say it was maybe 80% of what it was supposed to be, which would be outside of spec, but it was universally 80%.
Yeah.
MFL has no way to baseline that, right? Because it's an indirect principle.
Let's be careful about baselining it. It's MFL can approximate what that wall thickness is, but it won't fully understand what you purchased or what you think you have.
Gotcha.
Right? Because it's a measurement. So if you thought you had whatever it would be, 250, a 250 wall, and it's actually coming in at 80% of that, the MFL tool won't know if you bought 188 wall or a 250 wall, right? Because of that range tolerance. So it's really important to you as an operator or whoever's running the project to communicate to the inspection company what wall thicknesses you have there, and then that goes into the whole topic of TVC materials and all that fun stuff.
And so the third point that they brought up was corrosion within corrosion, right? So I'm sorry, it was actually the interaction of the corrosion pits was the interference is what I meant to go with there. Right, to talk a little bit about signal interference. What do they mean with that?
So I don't specifically remember the paper. So if you're looking at the paper and you read
Did you prepare for the show?
Yeah, I did, but I didn't.
I gave you the paper a solid 10 minutes before the show. I mean, there's at least enough time to skim my highlights.
Yeah, so
it's because you were still focused on the Super Bowl. Well, look, I'll take it, right?
No, go ahead.
So this one, this goes back to rocks and streams for me, right? So if you have lots of corrosion pits interacting with one another, right? Think about water flowing through the stream, right? So if I took a whole bunch of boulders, threw them into a stream, and then only gave you the velocity profile of that stream and said, here's how fast the water is at each point. Tell me how big every single one of the boulders is and where they're located. Yeah. Most people would go, you're crazy. There's no way you can do that. That's what we try to do with MFL, right? Because the disruption of the signal as it goes around one metal loss is still disrupted by the time it contacts the next metal loss. And if you get too many of those adjacent to each other, it makes it very difficult to get back to, I don't want to use the term baseline because you threw that one out last time. Yeah. But it makes it very difficult to get back to the reference point MFL needs.
Yeah, or to turn that signal into something meaningful.
Yes.
And so when I think of the word interference, the reason why I paused a little bit was because, so one way to interpret signal interference between one feature and another is exactly right, is it's the measurement principle of magnetic flux, it's not instantaneous. Right, so you have to think about, you have this flux line that is either in the material or not, and it doesn't change instantaneously. So you have to think like maybe we'll go a little bit electrical here. It's kind of like what we expect an inductor to do, right? It's to manage instant change, right? And so
I don't think I know what inductors do. I'm sorry. Or capacitors.
And so the idea is, once it leaks, it doesn't instantly come back into the pipe material if there's enough material for that much magnetic flux. And so there is going to be some distance or time from when a flux leaks to when it comes back into the material. And so that's one way of interference. So if you had a big feature and you had a lot of flux leakage, and then there's a smaller or even larger feature behind it or next to it, all of that flux that leaked originally may not be back in the material to provide enough of a signal response in our MFL sensor to detect what that true dimension or characterization of that, like you said, that nearby metal loss feature.
Yeah.
Another example is, depending on your corrosion morphology, you may have ferromagnetic debris or byproduct of the corrosion mechanism. And so that could also be magnetic flux conducting, I guess, where basically you have a true corrosion feature which can't bear the stress or the load, but it kind of tricks the MFL tool in thinking that it's not as deep as it actually is because the debris has magnetic properties in it. So those are two ways of thinking about interference.
There's, again, MFL sounds simple on the outside, but it's actually a fairly complex process. When I take a look at this, it's, to be honest, it's amazing that we as an industry have vendors and technology as good as we do. It's impressive technology.
Yeah, well, I want to jump in on that. One reason why that could be that we've had so much success with MFL tools, and let's be very specific. I think mostly what we're talking about is MFL-A.
I think for the purposes of today's episode, I'd say it's MFL-A.
Mostly MFL-A. And the reason why we've been so successful, I think, is because it's not just the inspection that matters, right? And the characterization of it, but it's the fact of what we do with that data.
Yes.
And I think that it's fair to say that in most cases, the majority of the efforts on how we respond to MFL data as an inspection, as it relates to integrity, is it normally has focused around ASME B31G calculations and modified B31G calculations, which only take two inputs into account to determine a burst pressure. Exactly. And so if you're really just looking, you have this big pool of corrosion, and you're just looking for its length, which we then use interaction rules on, which can be conservative, and you're looking for a depth, then as long as the MFL tool with pretty decent confidence can find where's that deepest pit, then you're going to do a pretty good job of keeping pipe round, sound into the ground.
So again, I want to go back. I want to just real quickly hit this, right? So when we talk about corrosion, we talk about complex corrosion, we talk about lengthy areas of corrosion, lots of missing material from the pipe, localized pits within that broader area. MFL is going to struggle. That was identified back in 2009.
Yeah, so let's be clear. It will struggle to characterize each of the individual features within the pool of corrosion. Back to your rocks in the stream. It could find the biggest rock in the stream, but it can struggle to find the size of all the rocks in the stream.
Agreed. And I think depending on how you're using that data, which you hit on, means that data could either be effective or potentially ineffective. Right. But regardless, I think complex corrosion, lots of corrosion, isn't a threat that's just, completely unheard of in our industry. And we're aware of operators that are not aware that in complex corrosion, long, deep things, this is a challenge. So as we move towards the next talk, I want to talk about what they learned in here, because I think the lessons learned for operators are really important. And let's talk about that, right? So first, I think it was easy. I don't want to spend a lot of time. They said focus on deeper corrosion. And they said 65%. So they had a kind of a robust process where anything over 65%, they instructed the vendor to put extra attention towards.
Yes. And I think that's good just in general. And I think that goes towards operators using, again, this concept of very simple but effective means of managing the integrity of their pipe. So if it's something like a burst pressure calculation, they don't use length and depth. Or we also want to identify where we have deepest pits. I think MFL can do a decent job of that.
The second one, and I think this one is really good, is they mentioned specifically targeting axially aligned corrosion. And I want to read it. So it says the vendor will group all features within a 2-hour clock position in width and equivalent length. Right? So what are they getting at there?
So the main takeaway there is it's and I'll reference a good piece of publicly known information, and that's what many people call the POF diagram, the Pipeline Operator Forum document on ILI. They have this document that has 7 different metal loss or 7 corrosion morphologies, right? Or not morphologies, but rather,
I had to count to verify you there.
Okay.
You're right. You did good.
That's okay. 7 different ways to classify corrosion. And the reason why they
Can
align...
you name all 7? Like you maybe name all 6 rap people? Never mind.
Do you want me to?
No.
Okay, I can. It's not that hard. And the point there is, it's if you have an actually aligned magnetic field and you have an axially oriented metal loss feature, the MFL tool will be compromised in its ability to best describe the length and the maximum depth of that feature. It'll do the width very well, but it can struggle with the length and the depth.
For me, this is like the rock in the stream, right? If the rock is really skinny, like it's like a, sticking out like a sharp iceberg, the water's just going to go right around it like a knife and come right back.
And flux does that, right?
Exactly.
So if you have something very crack-like, there's not enough loss of metal for there to potentially be a flux leakage or one that the sensor can detect.
Yep.
The flux can actually navigate around it depending on its aperture, its opening, and how long it is.
Absolutely. So again, one of the things they just took an extra step of asking the vendor specifically to group those features. The third thing they did was asking the analyst to look for signs of corrosion within corrosion, right? And I think that's pretty straightforward. But what stands out to me about those last 2 points, and I want to hit it real loud, and I want to get your thoughts on it, is in both of those, they collaborated with the vendor.
Yes.
And for me personally, I think this is important because they didn't go back to the vendor and say, hey, you guys missed the depth of this feature and we had a failure. They went back and looked to develop a solution with the vendor who has a very deep technical understanding of the technology and build on it. Your thoughts on that?
This gets really complicated really fast.
Wow. Like a whole nother episode type of complicated?
Very possibly.
Wow.
And so this is when we start thinking about things like API 1163. Sorry, I maybe ate something that...
No, I think Miss Producer just introduced unwanted noise into the podcast.
I think it was gas.
Really? We had another release of gas?
I don't know.
She's not. I'm sorry. You need to apologize.
I'm sorry, Miss Producer. I know breakfast does that to me sometimes too.
Oh wow.
Anyways, so I do think this is complex because this is where 1163 API 1163 comes into play, which is an umbrella document for really qualifying ILI systems, but it does a lot more than that. And so what I want to get to is this. We really need to understand the objective of the inspection. And that's one of the things that API 1163 really hones down on is we need to understand what we're trying to accomplish
this is definitely another
when
episode.
we perform an inline inspection. So
absolutely.
If you were doing a baseline integrity assessment using MFLA and you get all these metal loss features reported, one of the best things you could do is go to the POF diagram and say, it gives you different lengths and widths so you could classify all these metal loss features into categories. And if you have axial slotting, axial grooving reported, then you need to possibly look at either having a different approach to analyzing your MFLA data, like we see in this 2012 IPC paper, or you need to look at running a different ILI system.
So this gets, you mentioned really complex really quick. That actually builds, I think, a little bit onto the PPIM paper from this year and what TC and Baker Hughes did about looking at specification based on where the features come within the POF classification.
Exactly right.
But that's absolutely another episode. I think this is a point we're going to have to wrap it up. Otherwise, we'll be on here for an hour, and Miss Producer is already flashing her watch at me. So you're gonna probably, bet she's into crawfish. I think you're probably gonna have to bring her some crawfish to work. You might have to treat her to crawfish. Do you eat crawfish? Do you eat crawfish?
No.
All of our people out there. I bet you the people in Canada are probably like, what is a crawfish? And they're up looking right now. It looks like a miniature lobster.
It's like a mini lobster.
And let's see the grossest thing that we all do.
It's got some super yummy, like yellow oranges stuff.
That's the fat that comes out right as you're boiling. No, because the brain. So like after you break the tail off,
you
right,
squish
and you
the
clean
head
the
and
mud off of it,
you suck all the yummy orange yellow stuff.
Yes.
I thought it was the brains.
I don't think the brains actually. I think it's what we tell our kids to kind of freak them out.
I think we tell our kids it's butter.
Wow, the things we tell our kids, and they learn later on. Yeah. You probably tell them too. It's vegan, like the word it's all plant based. It's good.
I don't do that.
So again, on today's episode, just want to recap, right? The major takeaway from this is number one, a fundamental understanding of how MFL technology works. MFL is the oldest technology, but we continue to learn about it. If you miss some of these papers at conferences, some of them have some really good lessons learned here. In the case of MFL, what the takeaway is that it doesn't do well with everything. Yes. Right, it has some limitations,
but there are things you can do though, right?
To counteract.
So, yes, I like to call it post ILI engineering, right? Where you're taking activities to understand what the data says, and not just using or staying flat on your feet, right? And saying, hey, we normally do B31G calculations. I'll give you another one. For example,
you're going to get into an next episode.
I'm
we
telling
can't
you.
do it. What you're about to tell them is if you're just taking your dig data and running with it, that's not enough. But that's another episode, man.
Okay.
We don't have another 30 minutes. So look, if you like this episode, you're going to need to join us again, because I get a sense we didn't maybe intend to, but we're about to start getting into what to do with your dig data, how to make sure your tools are running right, and maybe what you can draw or what lessons you should learn, right? And all
like,
this.
what if I only have MFA data?
You're going to need to come back to the next edition or episode of Pipeline Things if you want to get the answer to that question. For today, I am your host, Thing 20 Rhett Dotson, and Thing 21 Christopher DeLeon. Thanks for joining us. Be sure to subscribe and leave us a review, and we will see you the Wednesday after next. Thank you.